morning, everyone. Welcome. I was in Brussels a couple of months ago, and I was asked to speak about nanotechnology in Canada to the EU. And I always start off with a map of Canada, and I show that there's certain pockets of excellence running across the country. But I always say, that there's only two $100 million plus institutes that are dedicated to nanotechnology in Canada, and that's the Waterloo Institute for Nanotechnology and the National Institute for Nanotechnology. And inevitably people ask, what's the relationship between the two of them? And it's too bad Dr. Carty isn't here today. He's actually leading a delegation in Japan, leading actually a Canadian delegation for Science and Technology and Society. But he helped found NINT when he was the president of NRC, and now that he's the executive director of WIN, he's ensured that there's a link or a relationship. The Director General, Dr. Marie Diorio, is on our board, been there right from the very beginning. And together with a bunch of other stakeholders have created a group called Nano Canada to represent ourselves sort of pan-Canadian and even internationally. So that's, so essentially we look at them as our sibling institute. So today we have Dr. Tyler Norsten, who's Director of NINT's Project Management Office, to give us a talk about their operations. So I'll give you a bit of an intro. So Dr. Norsten obtained his PhD in chemistry in 2001 from the University of Alberta, and has held a postdoctoral position at the University of Massachusetts Amherst and a visiting fellow position at the Institute for Chemical Process and Environmental Technology at the NRC. And that was before joining Xerox Research Centre of Canada, where he led multiple R&D projects. So he has a pretty broad range, actually, of international and industrial experience. He spent some time in Singapore, by the looks of it, as a research scientist and project manager at the Institute for Material Science, or Material Research and Engineering, and later, actually, a stint in the private sector to give that balance. So Dr. Norsten actually holds 25 U.S. patents and has authored over 40 publications. So his current interests are in streamlining R&D operations and the application of project management methodologies to early stage R&D initiatives. Does that sound good?
Is
that you?
That's perfect.
Did I get it right?
That's exactly right.
So please, everybody, welcome Dr. Tyler Norsten from NINT.
All right. Thanks, Alan, for the introduction. It's really nice to be here. I've never been to Waterloo before, University of Waterloo before, and I used to live I guess just out in Oakville, Mississauga. So this is a really good opportunity for me to come out and see the university and the institute. It's pretty impressive. My talk today is going to be, get the slides working, on I'm going to give you kind of a light dusting of what we're up to at NINT. With respect to the programs that we have ongoing at NINT and the NRC. I'll give you a little bit of structure of kind of how the new NRC is structured. It's kind of undergone some changes in the last few years, I think for the better. And I'll dive into some projects, not a lot of detail, some high-level slides that were basically provided to me by the project leaders. So if you see some questions and you want to dive into the data a little bit more, I can try. But it's not really my role anymore to perform the science. It's more kind of running the projects and the flow through there. So that'll kind of be the outline of my talk. If you ever need to get a hold of me, this is my information here. This website here is new. It's the new NINT website. We're not completely NRC and we're not completely University of Alberta. We're a partnership, and Marie, the executive director, has done a lot of work to kind of rebrand NINT. So this is kind of how the new NRC looks. It's divided into portfolios and programs. And there are 12 separate portfolios in the NRC, and they're run out of basically various institutes across Canada, spanning basically all of Canada. I'm going to focus in on the last portfolio. It's security and disruptive technologies. this is where NINT lies. NINT is a program in the SD Tech. That's kind of NRC speak for security and disruptive technologies. And there are 3 programs in there: the National Institute for Nanotechnology, security materials technology. They're working on new materials for instance, with the Department of Defense, those sorts of projects, and quantum photonic sensing. Those 2 programs are mainly run out of Ottawa at the old Stacy Institute, but we also contribute resources, both human resources and facilities resources, into those programs. So NINT contributes into a variety of different portfolios and different programs. And there's also a few what they call flagship projects. One of them is in printable electronics. One of them is the Canadian wheat flagship, industrial biomaterials and algal carbon conversion. NINT provides resources. We don't lead projects in these flagship projects, but we provide resources and expertise to help move these projects forward. If you want to know a little bit more about these flagship projects, there's this website here, specifically in the printable electronics flagship project. There's a consortium of companies who are all involved in basically providing innovation to printable electronics. So what is NINT? It's a collaborative program that is housed in the SD Tech portfolio. It was created in 2001 without a building. So people were housed around the university, and it's a collaboration between the National Research Council and the University of Alberta. So like I said, we're not, in the NRC, they kind of say that NINT kind of marches to the beat of its own drum. We're a little bit different. We work on more in the new NRC. We still work on new and early stage technologies, and I'll talk a little bit about that. But we also work with industry clients, and I'll highlight several projects that we're currently working on with industrial clients, because that's also a strong mandate for us, is to help Canadian businesses and Canadian industry further their R&D efforts. And so we have a fairly nice facility. It's not quite as new as this one, but it's nice. We have about 300 researchers, give or take, and that's based on the NRC staff, which roughly hovers around 80 to 100 of permanent NRC staff. And then we have U of A faculty. They're called cross appointees. So they have an NRC appointment, and they also run a group at the university, and they run projects at the NRC. And we house an innovation center. So on the 4th floor of NINT, it's a floor completely dedicated for company space. They can come in, they can set up a lab, they can customize it however they want, and they can work up in that space, and they can have access to NINT and the university. We have a strong EM facility. I think it's our kind of our crown jewel, and we have clean room facilities. So with respect to where we're located in the world, we're out in Edmonton, Alberta. I love it because I'm a hockey fan, and I can put in a rink around now, and it'll go, until around now. It's if you've ever been to the University of Alberta, NINT is really centrally located. Where's the pointer? Center one?
No, center of the room. Yeah.
I'll point it out. It's right. Well, we can see it right here. But what I really want to point out is it's really centrally located. All these are mechanical engineering, electrical engineering, all the engineering buildings wrap around here, and it's all interconnected by pedways. And then over here, this is the Center for Interdisciplinary Sciences. So we have biological sciences, we have physics, all these. This is a brand new building, so it's really nice. So it's very centrally located. So our clients on the 4th floor, they have access to NINT. They also have access to the university around there. No, that's the one that changes it.
Oh,
That's okay, it's okay. There's no problem. No problem. I don't like too much technology. Not good. Okay, so, and then this is kind of a map of industry in Alberta. NINT is basically also centrally located with industry. We have a lot of funding agencies, AITF. We have NATE, the Northern Alberta Institute for Technology. They also have a nano program, a technology school with a nano program. It's really cool, and they have fairly good facilities. So we're in pretty good shape location-wise. We're not as central as Ontario. I kind of miss being out here. You can take a direct flight anywhere from Toronto. Edmonton's a little bit harder to get to, but once you're there, it's nice. So please come out and visit NINT. We have a biochemical laboratories, a full suite of organic, inorganic analytical laboratories and clean rooms, and we have NRC technicians that look after those laboratories. So they look after all the equipment, they make sure it's all calibrated, working correctly, and they maintain everything, which is important when you're dealing with industrial clients who want to come in and ensure that the data in is good and the data out is good. And this is our what's called the NINT-Hitachi Products Development Center. It houses all the electron microscopes, so SEMs, TEMs, focused ion beam instruments. It's a very nice facility. A lot of our internal projects use this, and we run a lot of collaborative research projects that use this. A lot of clients come in and use this facility for testing and technical services. So now I'm gonna go into a little bit about the programs that we're currently running at NINT. So we have basically what I like to call internal programs that the cross appointees and the NRC staff are basically running projects in. And this is hybrid nanoelectronics, energy generation and storage. We have nano-enabled biomaterials. This is a new program. I'm not going to touch on that. We just got through our project planning process and approval process. So we're running 2 projects in this now in antimicrobial coatings and nano-enhanced packaging for, say, for foods. These are just up and running. Nano-enabled sensing and detection. And the last one, which is the one that I know most about because I deal a lot in client-based interactions, is industrial innovation support. And this is where we partner and help Canadian companies with their R&D problems. So this is the NASA technology readiness scale. And so where NINT really functions and was designed to function is in the kind of in the TR1 to TR3 level. So early stage from idea and proof of concept. So a lot of our internal projects are kind of targeting the 1 to 3 stage. And sometimes they, as you know, in R&D, things go off in crazy directions that you didn't plan in the beginning. So applying project management to early stage R&D, R&D is tough. So as a project manager, I'm kind of lucky because I have R&D experience, but in some of the other portfolios at the NRC, project management's a lot more rigid. So you just have to know how to apply the principles of project management to the actual project. And so I'll show examples of some projects that are in the 1 to 3, and then we have a few projects that have actually gone all the way to TR6, where you've developed the technology to the point of a prototype that is basically ready to hand off, and NINT really doesn't go beyond the prototype level. So I want to have one slide on project management. I really learned to appreciate project management in Singapore when I moved from A-Star, which is basically the equivalent. I used to work with Professor Yuning at A-Star. And when I moved to the private industry, managing projects, managing budgets, managing scope creep, and managing time is very important when you're dealing with industrial clients who these are all very important things to those types of projects. So my role here is a new one at NINT, and it's relatively new at the NRC, is to apply project management principles to the projects that flow through there. So SMART deliverables, which are stands for specific, measurable, achievable, realistic, and time-bound. So when we're planning projects, we want to apply these types of principles to the project plans and the deliverables. Making sure the project leaders are aware of the triple constraints in projects, which is scope, time, and cost. And defining and maintaining, this is probably where I spend most of my time at NINT, is defining and maintaining the process for project approvals. How are projects approved? What criteria is used for project approvals and selection, and project reviews? How are projects going? Are they on time? Are there problems that need to be resolved to make sure that the project meets the deliverables? Another big thing that I'm involved with is resource management. So making sure if we take a project on, do we have the adequate resources to complete the project plan? Do we have the right equipment to do it? You know, should we be doing it? And who's going to do it? Do we need to hire somebody to actually do this work? And the main thing, and I think if you read in the project management literature and just from experience, is improving the communication between the whole institute and the whole organization. So one reason why projects can fail, and I think one of the primary reasons is there's not good communication between management, project leaders, and the team. So I'm a big proponent of focused project meetings, not group meetings where say if you're running a big group and you just talk about what's happening in the group as a whole. You have project meetings with focused project team members and talk about the actual specific project that's actually going on. Next slide. Okay, so I'm going to attempt, I haven't given this talk yet, this is the first time, so I'm going to attempt to kind of give a brief overview of the programs and some specific projects that are happening at NINT. And so if you have some questions at the end, I can try to attempt to answer some of the technical things, but in a nutshell, this is just kind of an overview of what's happening in NINT, and hopefully you see something there that's exciting. And if there's any students out there, we do hire students at NINT to work on our projects. This is the Hybrid Nanoscale Electronics program. These aren't all the projects in the program, but it's a pretty representative example. And this is run by Dr. Adam Berggren, and that's his contact information there. And kind of a detailed description of the program is on the NINT website. So what Dr. Berggren's been working on, along with Professor Richard McCreary, is the application of these molecular tunnel junctions for diode onto diodes. And what they found was they could do some interesting covalent chemistry onto the electrodes here, and they could tune how the IV curve looked on based on the thickness of these monolayers. And what they found was, if you look at the one in blue, that's a kind of a regular diode without any monolayer on it, and the shape of that curve is vastly different than when you put a monolayer on it, and they can tune kind of the shape of that IV curve, and they applied this to the science of sound. And so what's pretty cool is on the next slide, there's this product called a distortion pedal, and there's a company in Edmonton. The guy's called Dr. Scientist, and you got to go check out his website. It's drscientist.com. He makes these distortion pedals, and he uses standard diodes to distort sound, but he doesn't have he can't really tune the sound that much. He has to kind of change his diodes, and so the actual diodes, the molecular tunnel junctions, are just basically SIM cards, and they slip into here, and then you can turn the knobs and you can alter the sound. But what's really cool, I don't know if I'm hooked up for sound here. Am I hooked up for sound? Forgot about that. Oh, that's okay. I can try and do it, and if I'm not, then you'll have to take my word for it. I couldn't get it into the movie, but when you switch the molecular tunnel junction on and off, you get a change in sound, and you can tune that sound based on the length of the molecular junction. Let's see if this works. No. Sorry, you can't really hear that, but could you hear kind of the change in sound? I'll play it again. So this is the junction on. It's a deeper, richer sound, and so this Dr. Scientist is now licensing this technology to create different sounds for his distortion pedals. And there are some other applications that the team is looking at, but this is one example of a project that has gone from idea conception, all the way to prototype stage, and we're ready to spin this off as a small company and see how it goes. And what was really cool is that Lucas here is from Waterloo. He's on his second term now, and he's contributed a great deal into the development of this project. So this is an example of a project that NINT had with Xerox. I'll go over the kind of the more broader details of that interaction a little bit later on, but Xerox was interested in finding applications for a polymer that they developed. It's called PQT. It's in the green. It's a polymer semiconductor in the green portion of this device, and they wanted to partner with NINT to develop a process for the assembly of the device and to develop a prototype Redox memory device. So this project's now over, but Xerox was able to get a prototype device that worked, and they got field of use IP on the device, as well as NINT. They were able to both IP this technology for separate fields of use. And this is just an example of the prototype device that was made. NINT was able to help make this device for Xerox, characterize the device, and we were able to subcontract some of the work for the fabrication of the device out to a local SME to provide work in that project as well. This is some work in nano-enabled sensing and detection. This program is led by Dr. Wayne Hebert. And this is some of Wayne's work here, where he works on nano-optical mechanical sensors. And the idea here is that you can detect. He's working on gas-based sensors, where he fabricates these optical racetrack resonators, and the light comes in on a photonic waveguide, and you can measure the analytes at the cantilever racetrack resonator interface, and he's shown that he can get fairly good signal to noise. He's got some better data than this, but you're actually measuring frequency of the resonator, as opposed to he's got the flame ionization signal at the bottom. The nice thing here is you can fabricate these detectors are ultra small, and if you can wire them up right, you can have a lot of them in parallel. So he's working on this for portable gas analysis. Another avenue that he's working with another professor called Professor Larry Unsworth. He's a chemist at the University of Alberta, and those sensors don't work very well in liquid systems yet, but they're devising a mechanism where they can do molecular imprinting onto the NEMS, and with the molecular imprint, they want to basically quantify absorbates of the molecular imprints that are on the surface of the NEMS, and this is some of the chemistry here on the right-hand side that Larry Unsworth is developing to make these molecular imprints right in the sensor. And this is an impedance-based sensor that Professor Ji Chen and Professor Mark McDermott from the U of A are working on. It's basically the idea here is to be able to detect set target biomarkers, and in this example here, they have interdigitated electrodes, and in this case, they're trying to target on the left. They are trying to target 8 different biomarkers. So each of these squares is basically a different sensor for a different biomarker. And the idea here on the right-hand side is that a biomarker can come in. There's a molecular recognition element on the gold surface. When it binds, it releases and allows a gold nanoparticle to attach to that sensor, and they can do impedance-based sensing based on the biomarkers in solution. So that's some work that's going on there. And finally, there's some work on graphene membranes. We have a facility that we can fabricate carbon nanotubes and graphene, and developed a proprietary process for developing graphene. And so what Dr. Ken Bosnick, he's an NRC staff, he's exploring graphene-based devices for gas analysis, for gas sieving and gas sensing functions. And one of his applications that he wants to do is use these graphene-based devices in the Nano-enabled biomaterials program for gas sensing in food packaging. So he's going to be a project leader in the new Nano-enabled biomaterials to explore graphene in food packaging. Last but not least, of the internal programs I'm going to talk about is energy generation and storage. This is led by Dr. Michael Fleischhauer, and he's an NRC staff. So there's a lot of work going on here in photovoltaics. This is some work by Professor Mike Brett, who basically invented this glancing angle, this GLAD deposition, and it's a way of depositing thin films in structured arrangements. Professor Brett just retired, but he's still at the university. He was running a very big group, so he said he would retire now, so he can actually retire in about 3 or 4 years. So I see him all the time at the university. But one thing that he's developed here is a way of structuring, in the organic semiconductors and photovoltaic fields, you want a certain level of structure in there so charges can go to where they're needed. And so this is one avenue that they're using to develop structure in the organic photovoltaics. So here he's put down copper, phthalocyan, and nanorods on top of ITO. This is some work by Jillian Buriak. She's also working in the field of organic photovoltaics. She's taking a slightly different approach where she's using polymer semiconductors in her process. This is very, very general, but what she's focusing on now is she thinks she has some pretty good materials, and she's working on scaling up from lab, her processes from lab to manufacturing, and she's looking at using approaches like spray coating and laminating her solar cells together. And this is kind of a neat device that Dr. Ken Harris made to help Dr. Jillian Buriak characterize her solar cells and finding out why things were not functioning as they should. He developed a stretching testing apparatus so he could develop. Dr. Buriak was also developing transparent conductors, and so he developed this testing apparatus where he could measure the electrical and optical properties as you mechanically stress the organic, the transparent conductors. So we have this kind of unique testing and engineering capability there. And this is a project that has moved quite quickly. Dr. Mike Taschuk, he's an engineer. He's an optical engineer. He's developing a prototype, and he's almost at the point of a solar simulator. Typically, the solar simulators are fairly big, bulky instruments. They're expensive, take up a lot of lab space, and if you're running long testing experiments, there can be fluctuations in the bulbs. So he's developed an LED-based solar simulator that can make quite small for lab-based testing, for prototype testing, and he's matched the solar spectrum fairly well, and he gets extremely stable output. And so the idea here is if this project's successful, he can hopefully develop a product based on LED solar simulators. And this is an interesting project that Dr. Mike Fleischhauer is working on. So energy storage. So where most work in this field is happening right now is in lithium-ion batteries for making them thinner, more powerful for mobile devices, electronics, and whatnot. Dr. Fleischhauer is looking at improving the safety and performance of different kinds of batteries. They're lithium thionyl chloride batteries. They're pretty nasty batteries. They're used in downhole tooling. So out in Alberta, we have a lot of oil and gas, and these batteries are integrated into downhole tools that go deep down and dig. So they have to be able to move and power massive drill bits downhole. And so they usually use these lithium thionyl chloride batteries. They don't work very well at low temperature. You have to heat them up. One of the things that Mike says, and he found out that happens out in the field, is the people who are working basically put the battery on a block and heat it up with like a torch. And so you don't really want to do that to lithium and thionyl chloride. So it's in certain instances, explosions have happened, people have died. So there are major safety issues with these batteries. So what Mike's done is he actually contacted Engineered Power, found out what some of the issues were, and he's starting to work on improving safety for these batteries. The project that he's working on here. Oh, next. Okay. Here's an example of a cell that he's made. He's trying to integrate a heating system into the battery, so the battery and the electrodes can be electrically heated instead of heating them up with a torch. And so that was a big thing for Engineering Power. That's a pretty big innovation. And so this is an example of a battery that he's going to test, and he's built a box. And these batteries need to be able to run in low temperatures, because believe me, it gets to be minus 50 in Alberta, and up to around 200 degrees downhole. It can get very hot. So, and he's going out to Ottawa, so we're leveraging some testing capabilities out in Ottawa, where he's going to explode some of these batteries. So he's pretty excited about blowing stuff up. And finally, I'm going to talk about industrial innovation support. This is a program that's it's kind of a catch-all, but it involves all the work that we do with industrial clients, and this is the work that I'm most familiar with, and this is where I spend a big chunk of my time keeping projects on scope and on time and on cost for the client. And this is led by Dr. Andrew Miles. So the idea here is that there's kind of a core group of NRC people on the innovation support team that when a client comes in, they provide a scope of work. We work with the business management services. That's another branch of the NRC, and they work with drafting agreements and discussing client needs. I work with the innovation support team and the client to define what the project will look like, timelines, budgets, and that sort of thing. And we do leverage expertise from the NINT program. So if there are people working on NINT program projects, like the ones that I just listed, who can provide expertise into these projects that we scope out, we can leverage some of that expertise and some of that time. And so what we're really trying to do is work and provide the expertise to the company to further their products. So this research is really client-focused research. It began right at NINT's inception. So these projects are basically over, but they were big. They're examples of big projects that NINT has undertaken. So one is with Hitachi, and the Hitachi name is still on the NINT building. So they invested a lot of money at the inception to have the Hitachi Electron Microscope Product Development Center, and so it was a $15 million partnership with Hitachi, Western Diversification, AITF, which is Alberta Innovates Technologies Futures. It's a Alberta-based granting agency, the U of A and the NRC. And so I have an example of a project that's ongoing with Hitachi, although the primary partnership or funding, I shouldn't say partnership, but project has ended. Basically every year we have ongoing smaller projects with Hitachi, and Xerox was at NINT. This has just ended last year, but they were at NINT for 5 years, and they ran a variety of different projects. You saw the one on the Redox memory devices. So this is a project that's ongoing that I'm actively managing with the project leader, Dr. Marek Malik, and he's developed a centralized control system for TEM, and this is basically a system that helps a TEM operator manage complex in situ TEM experiments. So when they want to add gas at certain times and do actual chemistry in the TEM, it can be very demanding to be turning all the knobs and then going back and looking in TEM. And so this is a centralized system that NINT and Hitachi have co-developed to help the TEM operators perform those types of experiments, and it's all done through a network system, and it's called Maestro, and it's now a product that Hitachi offers. It's still being developed because every TEM is slightly different. So Dr. Michael Bergen, who is the researcher on this, doing most of the work, is traveling out to we have 3 locations we're installing Maestro in around Canada this year, and we have 3 more to be installed next year, and some of them are in international locations. So this is a project that is ongoing with Hitachi. This is a project that just ended, was run by Dr. Andrew Miles, but JetLube is it's an American-based company, but it has operations in Canada, and what they do is they make lubricants for the oil industry. And they noticed that that some of their competitors were starting to offer nano-enhanced products, and they were wondering, well, what is a nano-enhanced product? And we actually had an industry day, and they showed up, and they were able to leverage, with the help of Andrew, they were able to leverage money from Alberta Innovates Technology Futures to help fund a project. And Andrew, within 18 months, had a process and a formulation of adding very cheap nanoscale ball bearings into their already existing formulation, and that was key to the client. It needed to go into its existing formulation. They couldn't reformulate. So Andrew was able to provide these nanoscale ball bearings into that and improve the the lubrication process. So that's completed, and they're actually now, they were happy with that project, and they're now negotiating a new project without Alberta Innovates Technology Futures. So that just goes to show that they were very happy with the work that we were doing in innovation support. This is another project that's pretty cool, where again, Andrew Miles was the lead researcher, and this is a company based in Edmonton. It's called Exciton Technologies, and they make silver salts on bandages for wound dressings, and these are commercially available products. They're fairly specific, and they sell them into like primarily like hospitals and healthcare institutions. And so they have a roll-to-roll process in downtown Edmonton that they manufacture these bandages. And one of their issues they were finding was they were getting degradation of their silver salts, and they wanted to address that. So once again, Andrew was able to leverage funds from AITF and put together a project. And one of their thoughts were they needed to develop new textiles, or actual the material that the actual bandage and silver salt is adhered to. They had found that the actual substrate was involved in the decomposition of the silver salt. So Andrew was able to develop a new process for creating fibers with the silver salt already in it, and was able to get stable wound dressings. And now this project is, it's actually ending this month. And we just signed a new agreement for a new project with a different project leader to address the issue of she's in the area of biological sciences. She's a biologist, and she's going to study, are these wound dressings, are they actually healing the wounds? So she does this by growing cells and studying the output, and also are these wound dressings antimicrobial? Are they as antimicrobial as before? So, and this is actually the project leader that is taking on the Exciton project. She's super busy. She works in the area of testing of growing cells and seeing how the cells react to different conditions. And she has told me that in certain countries they have banned the use of animal testing, and this basically is a substitute for animal testing, the testing on human-based cells. So there's a lot of companies coming to her asking her to do testing on their products, and this is one company, CPro. It's a company based in Leduc, Alberta, just south of Edmonton, and they've developed processes for extracting natural ingredients from oats, and these oat products. If you've ever heard of Aveeno, do you know the line of products, Aveeno? I know it because I have kids and my wife. It's expensive, and I'm like, why are you buying this stuff? But it's because it's all natural ingredients, and it's very, they say it's very healthy and good for the kids. So anyway, it's and Jennifer Aniston is their new spokesperson. She loves it. So. But CPro is the one who developed the process for the extraction of their primary ingredient is the oat ingredients, and she sells that. That company sells it to Aveeno. So she has multiple. They love Mariana. I love Mariana. She's great. She's a hard worker, and she's had continual interactions with CPro over the last 5 years. So. Good. And then this is a NINT spin-off company. I think our first spin-off company. It's called quantum silicon. I'm not going to go into too much detail on this, mainly because it's above my head, the technical details, but the idea is, this is Dr. Jason Pitters and Bob Wolko. So it was an internal project for many years, and Dr. Wolko spun the company off. It's now called Quantum Silicon. They're now headquartered up on the 4th floor in the Innovation Center, but they still use the labs and some of the resources at NINT. And the idea is to basically redefine computing using kind of quantum scale and atom scale devices. So it's pretty neat stuff. Lockheed Martin is also, in the last year or so, developed a relationship with the company, so they help fund that project. It's pretty long-term stuff. So, our approach at NINT is the collaborative approach, basically leveraging NRC, leveraging university staff. We have fairly good expertise at the forefront of nanoscale. We have very good instrumentation. And I hope I've shown you that we've provide innovative applications and help the kind of the commercialization of nano in Canada. And so with that, that's the end of my presentation. I'm really happy to be here at WIN. I get to see the institute and meet some of the researchers, and hopefully there's something here, something that kind of catches your attention, and hopefully we can work collaboratively together. So with that, thanks for your time.
Very good.
Cool.
Thank you.
Thank you.
The official handshake. As probably some people have to get out, but I'd like, if there are a few questions. Can we have a few questions from the audience? Well, let me get one going. Maybe that'll get you thinking. So you're from the industrial or the innovation component side of it, and we had seen 4 themes, which seem to get structured strategically in NINT, and so they're moving forward. This is a question, how does an external partner or industry come in and interject itself into the process along those technology readiness curves, I guess? How do you get in?
Yeah, that's a good question. So there are basically 2 ways through our business management services that they actively go out and basically tell NINT what's going on, or tell the clients and out there like what's going on at NINT and what we can do. So kind of, word of mouth, or a client can come directly to the project leader. So and that's what's been happening a lot with Dr. Andrew Miles, the program coordinator. They'll hear word of mouth. Okay, NINT has this expertise. They can do this kind of work, and they'll contact Andrew, and he'll sit down with the client. We either over the phone. We work with clients out in BC, not so much out in Ontario yet. I'm sure you guys have a pretty good connections out here, and we'll sit down and define what they need, and if we can do it, kind of get a scope of work going, and it'll kind of go from there. So
maybe just an additional question there. So how do you deal with pre-IP and post-IP? So in the case of Xerox or whatever, they do have a portfolio. They want to bring it to bearing, but it's theirs to start with. You create something, and then going forward, split, shared. How does that transition work as well?
So with the Xerox agreement, that was so we don't work a lot with multinationals. We're more focusing on the SMEs. So the Xerox, I used to work there, so I know how important IP is to Xerox and owning it. So in that situation, it was based on field of use IP. So if Xerox wanted it for inks and toners, it was fine, and NINT could get any IP if it was used for, say, paints and and flooring or something like that, right? So that one was structured a certain way. Typically, IP at the NRC is owned by the Crown. So the Crown owns the IP that is generated, and then the company is free to license it. So.
Any other questions from the audience? Okay, well, I see a number of students in the audience. I'll make one last audience-oriented question. How's that? I'll ask on their behalf. So I know one of the very first co-op jobs we ever secured for the Nano undergrads.
Yeah.
Was it yours, by the way? Yeah, it was his. Very first one. We called in. How long ago was that? 9. Yeah, right, a long time ago. We called right in through the front door and we said, so we've got a bunch of smart people here in the area. How do we get in? And you worked in Wayne Materials Lab?
Yeah.
And what was that? That was the
nanobiological robots.
Yeah, that was a few nanobiological robots. So the question then, from an audience perspective, is: so if any of these guys, whether it be undergrad or grad, are interested, so I asked the industrial question from their perspective, how would they contact and be interested in getting into NINT?
Well, I would go to our website. It's the best way. I'm not in human resources, and we've decentralized our human resources. So our human resources people are in Ottawa. But the main way to do it is to go to the website here, and in there there are each of the program coordinators. So all the email addresses are right there, and you can see the best way is to find out if there's a specific project that you see. All our projects are basically listed there. You can contact the person directly, and then they hire based on like a kind of project needs. So that's probably the best way of doing it.
And now they know you, and they have your contact details.
And or you contact me, and I can handle it too.
Exactly.
So
That's it. Well, one more. Yeah, sure.
Just sort of down the line, like not necessarily working specifically for NINT, but some of these project collaborations that are going on. Surely they go in another direction and continue to grow and need support. Are there like lists of these projects that have either been completed and are moving on available for fourth-year students who are jobs after graduation?
like a list of projects that are ongoing at NINT?
Ongoing or have been completed? Or
Yeah, that's a great question. I don't think we have that. I mean, we have the ongoing projects mainly on our website, but not the completed projects. But that's what some clients. So the internal projects, we can do that. The external clients, when you're dealing with a external client, some clients like there's 2 projects that I really wanted to talk about that I thought were really cool, but the client doesn't want us to talk about them. So in certain instances, we have to maintain confidentiality. So the external projects, so the ones that I did discuss today, we got permission from the external client to discuss, even though it's very general, that we're actually working with them and kind of what we're doing. So, but that's a good point. That might be useful to have that on our website. So, thanks for bringing that up.
Well, listen, the NRC is a pillar of science in Canada, right? And the new NRC indicates it's gone through a bit of change. So it's interesting to see some insight into how you structure things. So perhaps we just thank our speaker very much. Thanks very much, Dr. Norsten.
Yep. Thanks for having me.
All right, and thank you everyone for coming out today. That was great. Thank you so much.
Yeah.
Go for some lunch.
Yeah.